Compare the domain and range and any existing intercepts of the cubic function f of x equals negative x cubed minus 2.5 and its inverse, the cubic function g of x equals the cubed root of negative x plus 2.5. Okay, so looking first at the domain and range, we see that this is a cubic and a cube root function. There, you can plug in any x value. There's no limitations there. And also you can get out any y value. So it's all real numbers. We can write that in interval notation as negative infinity to positive infinity. Okay, now let's find the x-intercepts of f of x and g of x. So for both of these, we need to recognize with an x-intercept, then we know that f of x, or y, equals 0. So we can just plug that into the equation and then solve for x. So if we plug in 0, we get 0 equals negative x cubed minus 2.5. So working from the outside in to isolate x, we add 2.5 on each side. So we get 2 5/10 equals negative x cubed. So now we can take the cubed root on each side, and that basically just undoes the third exponent. So we're left with just what's underneath. We're left with negative x equals the cubed root of 2 5/10. Okay, so we still have a negative x, so that's like having a negative 1 in front, so we can just divide by negative 1 on each side. So negative 2.5 divided by negative 1 is just negative 2.5. So we have the cubed root of negative 2.5 equals x. Okay, so now let's just put that in our ordered pair. That's going to be our x value. And then 0 is our y. All right, so let's keep going. So x-intercept of g of x. Again, g of x here now will equal 0. So let's plug that into the equation. So we have 0 equals the cubed root of negative x plus 2.5, or 2 5/10, whichever you prefer. Okay, so we can't get to x unless we first get rid of this cubed root. And we can do that by using the opposite operation, which is raising it to the third on each side. So that cancels out our cubed root, and it just leaves us with what's underneath. And 0 to the third is just 0. So now we have this negative in front. We needed to go ahead and distribute the negative. So we get negative x minus 2 5/10 equals 0. And now we can add 2.5 over, or we can actually just add this x, and that way this will also solve it for x. So if we add x over, we get 0 plus x, just x, equals negative 2.5. And a lot of students don't think that they can move the x, but you actually can. Or you could have moved the other way. It just adds another step. So we now get our x value. And so our final answer here will be negative 2 5/10, 0. Okay, so now let's do the y-intercept of f of x. With y-intercept, we know x is equal to 0. So we can just plug in f of 0. And so we have negative 0 to the third minus 2 5/10. Negative 0 to the third. Well, 0 to the third is just 0. So negative 0, that's just 0. So we have 0 minus 2 5/10 equals y. So then we have negative 2 5/10 equals y. Okay, so let's go ahead and put that in our ordered pair. So we have 0, then negative 2 5/10. All right, and lastly, y-intercept of g of x. So again, x will equal 0. So we can plug in g of 0. And then we have 0 plus 2 5/10. And then the cubed root. So 0 plus 2.5 or 2 5/10 is just 2 5/10. So we have negative 2 5/10. And that is our y value. So let's go ahead and put in 0, cubed root of 2 5/10. Okay, so we now have all of the different things that we need. And just notice that the y-intercept and x-intercept are inverses, and so are the x and y, the other pair. So this does show that it is an inverse function. So both domain and range of the functions include all real numbers, negative infinity to infinity, the x-intercept of f(x) and the y-intercept of g of x are cubed root of negative 2 and 5/10, 0, and 0, cubed root of negative 2 and 5/10, respectively. The approximate value of cubed root of negative 2 and 5/10 is negative 1.357. The y-intercept of f(x) and the x-intercept of g of x are 0, negative 2 and 5/10, and negative 2 and 5/10, 0, respectively.